I'm Daniel Jenkins, Regulatory Program Manager here at Skydio, and I want to thank you for taking some time to attend this webinar and learn more about Skydio's regulatory team and our approach to scaling utility operations. So first, why summiting Mount Regulation? Now, the peak of Mount Regulation is really fully autonomous operations. So this provides data at scale without significant human oversight. And that supports the level of data needed to transition from time-based maintenance to condition-based maintenance. Now, right now, there's not a defined regulatory framework to enable advanced drone operations, much like an uncharted mountain. And like a climbing expedition, the work we do is guiding folks on a journey toward that end goal. And one thing that helps you navigate the regulatory process is having expert guides to help you find that pathway to the summit. And our goal is to be that expert guide. So the regulatory team here at Skydio is small but highly experienced. Really, we are pilots and operations-minded individuals. So we understand what it's like to be out in the field trying to get value from drones. Now, personally, I've worked in advanced drone operations for the past 8 years. Prior to Skydio, I was at the MITRE Corporation, where I worked with state and local agencies like the Massachusetts Department of Transportation. So with MassDOT, I developed a statewide railway inspection waiver and worked directly with their inspection team on the design of those operations. And before MITRE, I was on a flight test team, flying drones at crewed aircraft to test automated avoidance systems. Those operations carried a lot of inherent risk and really embedded operational and aviation safety into how I approach planning advanced operations. I've also worked on some industry consensus standards bodies around automated avoidance technology and contributed to the standard that informs the required performance of those systems today, as well as the test methods for determining that performance. Across my career, I've developed over 20 BVLOS waivers across various organizations and enabled BVLOS operations for nearly a dozen utilities, some of which are with us here today. Now, the drone regulatory landscape is really based in Part 107, which the FAA released in 2016. Now, Part 107 requires that the pilot operate within visual line of sight. And to fly beyond visual line of sight, you need a waiver for FAA regulations. So beyond visual line of sight, or BVLOS, is a term you're going to hear me use a lot today. And effectively what BVLOS means is flying where the pilot can't physically see the aircraft. So this can mean the pilot is out in the field and can't see the aircraft, though it's near them, such as on the other side of a building, over a tree line, or too far away. It can also mean that the pilot is in a different state entirely, flying aircraft from their computer. So additionally, the remote pilot must have a remote pilot certificate. And there are some other limitations as well. To be able to operate outside of those constraints, you need a waiver. So why should you be interested in regulatory services for your drone programs? Now, visual line of sight is limiting, resource intensive, and time consuming. With all the repositioning that's required to keep that drone in line of sight, you end up spending a lot more time driving than you do flying. Now, the FAA process to get a waiver to go beyond visual line of sight requires specialized technical documentation, which can be complex to generate for your operations. The complexity of this process and the technical detail involved results in about 7 out of 10 waiver applications being denied. Now, I can say that Skydio beats those odds pretty handily. Now, about Skydio, we are the largest drone manufacturer, and we've worked with over 100 utilities here in the US. Now, we go on site with the utilities and work hand in hand to value far beyond providing the equipment, providing experts in utility operations, experts on equipment, and experts in the regular process to enable operations. Coast, we've written waivers enabling inspection of thousands of substations, tens of thousands of miles of utility infrastructure, and 100 power generation facilities. Under these rules, we have utility companies to meet their regulatory requirements, such as flight inspections, with efficiency and increased safety by taking the out of proximity to that energized equipment or off of ladders or lifts, which pose a hazard. Now, what does this technology ultimately mean for your operations? Well, drones are really a data collection tool that's used to provide the levels of data needed to be able to transition from time-based maintenance to condition-based maintenance. Time-based maintenance carries risks with components that are being replaced too early, driving up that cost over time, or components that are replaced too late, which results in a failure that causes more damage. Fully transitioning to condition-based maintenance does require a significant amount of data. You need to be able to track each component, and that requires regular inspections at regular intervals to be able to build that history of the health of the assets and components. Now on the left here, we have manual inspections, which are time and resource intensive and provide limited amounts of data, often in the form of images taken by hand or just in reports. Now, as we move to the right, the first integration of drones typically involves line of sight operations. This carries many of the same limitations as manual inspections. And this can also be done beyond visual line of sight, which extends the range that each mission can be flown around the asset, but does require a waiver. So the limit here is really that you still have to send people out into the field. And so you don't see as significant a benefit versus transitioning into remote operations, where you really start to see those increases in efficiency and the amount of data that you can collect. So remote operations removes the need to get personnel on site to collect that data, which lets you scale. Instead of having somebody drive out, physically prepare the drone, and then launch it, instead they just sit at their computer in an office and connect to the dock drone. So you may have heard of this as a drone in a box concept, but effectively the dock is able to handle many of the manual parts of the operation and keep the aircraft protected from the elements. So beyond that, the next level of scale and what really will enable system-wide transitions to condition-based maintenance is central digital monitoring. In this method of operation, one pilot is overseeing many flights occurring at the same time. This lets you scale your data collection without requiring a proportionate scale of your headcount. This is a little bit more advanced, and so we're going to come back to this toward the end of the presentation. Now, what you're seeing on screen is what we call the arc of autonomy for drones. This maps pretty closely to the previous slide. And one thing to note here is that the green check marks above each of the stages denote where we have received regulatory approvals. So starting at stage 1, this is where you're sending your frontline staff and pilots out into the field to manually fly the aircraft. This is really useful for getting the technology in field, but really doesn't enable the benefits of drone operations to their fullest. Now, as you move right into stage 2, you're adding more automation for the pilot flying. They still need to be in field, but now there are tools such as mission planning and collision avoidance that reduce the pilot workload and increase their ability to operate safely. Manually flying near wires and other structures is challenging, and these tools help reduce the risk of flying into a structure. Now, stage 3 is where the operational benefits really kick in. So this involves having that dock drone at your site, and instead of sending the pilot to the site, the pilot can remotely connect to the aircraft from their office and conduct the inspection. The drone lives in the dock on site, and then the dock allows the system to remain on site, ready to launch a mission at any point you need. The remote pilot can then connect from anywhere in the US and fly that aircraft instead of needing to go out and fly the mission via controller. The dock also, in addition to protecting that aircraft from the elements, aids the pilot in meeting some of the regulatory requirements for pre-flight inspection of the drone and ensuring it's in safe condition for operation. Now, stage 4 really steps up the scale at which you can conduct these operations. So this is getting into that central digital monitoring. This involves one pilot operating many systems, and the yellow check here signifies that we've received an internal Skydio approval for this, but we just aren't quite ready to push this out for full customer use. We do have a regulatory pathway here, but we still need to finish a rigorous internal testing program. Now, stage 5 is the ultimate goal of integrating drones into your programs. Now, this is the peak of mount regulation. This is the end state of condition-based maintenance. And this removes the pilot from the operation entirely and uses autonomous operations to supply data on schedule or on demand without a human being required to fly that mission. So for a little bit of context on the regulatory history around utility operations, starting back in 2022, we helped Dominion Energy with a power generation facility inspection waiver. Now, this required the remote pilot to be on site, acting as a visual observer, which maps back to stage 2 of the arc of autonomy, or using frontline staff with drones manually flying missions. Moving forward to 2023, we saw some pretty significant improvements. Both Dominion and New York Power Authority received approvals for dock remote operations, pulling that pilot off site and reducing the number of truck rolls required to get those pilots to locations and be able to get data from those locations. With Southern Company, we were able to get more altitude, supporting more efficient mapping missions, inspection of larger assets. And with PG&E, we were able to expand the area where a dock can operate. So in the context of substation inspections, this allows operations along the utility lines running into and out of the substation. So one way to think about this is operations, inside the fence, where you're within the substation controlled area, versus outside the fence, where you're operating along right-of-ways and property that you don't control access to. Now, this year, we've been expanding critical infrastructure operations, which we'll discuss in detail a little bit further. And we've been enabling operations closer into airports and expanding operations using our newest system, the X10. So with these approvals, there are a few main considerations that need to be met to demonstrate to the FAA that an operation can be done safely. And when you're pursuing a waiver, that's ultimately the question that you need to answer for the FAA to be able to grant that waiver. Now, fundamentally, this means you need to mitigate air and ground risk. Air risk being collisions with other aircraft, and ground risk being collisions with persons or property on the ground. So we take advantage of the technology on board Skydio aircraft, some specific operational designs, and airspace awareness technology to satisfy these requirements. So let's look at those components in a little bit more detail. When looking at the air risk side, one of the main strategies we use is shielding. So you may have heard of it as masking or close proximity limited altitude operations, but essentially it involves flying near things that aircraft try to avoid. Now, there have been some studies that demonstrate there is a significant reduction in the likelihood of a collision with another aircraft in these environments. And that goes to help support the air risk component of the safety case that we present in these waivers to the FAA. Now, there are two types of shielding based on what is being overflown: critical infrastructure and non-critical infrastructure. So for non-critical infrastructure, this covers things like utility line inspections, while critical infrastructure includes things like your power generation facilities. Now, there isn't a clear-cut definition of what critical infrastructure is, but Skydio works with both you and the FAA to ensure that we get the maximum altitude for your sites to support the largest variety of use cases that you may have. Onboard autonomy is really what makes a Skydio drone unique. With the onboard collision avoidance system, Skydio can operate in confined and complex spaces without requiring an expert pilot or posing a risk of damage to the nearby structures. With the addition of night sense on the X10, we can enable this obstacle avoidance at night as well, further reducing the ground risk of that operation. Now, geofencing is usually a regulatory requirement for these operations, and Skydio Sites enables 3D keep-in and keep-out geofencing, which satisfies the regulatory requirement and provides an increased operational safety by reducing the potential for pilot error when they're navigating the drone. Safe landing designations further reduce the risk of people on the ground in the event of an emergency with a drone, because you're able to identify areas where people either can't access or will not be, and make sure that in the event of emergency, the drone is navigating toward those locations. So you couple that with the onboard avoidance, mission planning, the navigation systems on board Skydio drones. This provides precise and readable positioning of the system in the environment, which really enables the ability to automate repeatable inspection missions. And all of this goes toward demonstrating that the drone is not going to pose an additional risk to people on the ground, and really supports that ground risk component of the argument. Now, the last layer here is ADS-B, or Automatic Dependent Surveillance Broadcast. And we use this coupled with shielding to help secure waivers. Now, at a high level, there are two components to ADS-B, out and in. And these function about how you'd expect. ADS-B out broadcasts position information as well as heading, speed, and some other info. And ADS-B in receives this information, and then it can be displayed on a ground control station or GCS for the remote pilot situational awareness. Now, with shielding, we fly where aircraft are not expected to be, but drones still have the regulatory requirement to give way to all other aircraft. So on the right, you can see an image of the GCS map view and the information received from the ADS-B out, which is translated into a pip on the screen that shows the location of the aircraft as well as the altitude and speed. So with the development of the X2 dock in 2023, Skydio began integrating ADS-B in for remote operations to provide that situational awareness to the remote pilot for aircraft that are transmitting. Looking at the right side of the screen here, this is how we display ADS-B information in remote flight deck, and filtering has been integrated with that ADS-B functionality. This also includes automated alerts for the remote pilot when an aircraft transmitting ADS-B gets too close to the drone. That alert is both audible and visual, which satisfies the regulatory requirement for alerting that we typically see in certificates of waiver. And certificates of waiver are the document that the FAA issues to you when they approve a waiver for your operations. And that contains a list of items, conditions and limitations that you need to comply with. So this ultimately aids the remote pilot in choosing the best course of action to avoid a potential collision and ensure that that operation remains safe. So rolling all this up, what does this approach mean for you and the operations that we can enable today? Well, really, ADS-B is simple to use alongside Skydio automation. The automated alerts and information displayed to the pilot ensures that they are able to avoid potential collisions with other aircraft without it being a significant workload for the pilot to manage and interpret all that airspace awareness information. ADS-B and shielding are really easy to scale across your service area. The equipment is lightweight and affordable, and while shielding does limit the altitude, many of the use cases that you will need a drone to accomplish often require positioning close to the equipment that is actually providing that shielding. So this is ultimately the most streamlined and simple way to get your drones flying useful, fully remote missions today. And we've demonstrated that this is a repeatable regulatory approval. As that regulatory hurdle has been cleared, this means that you can scale with this technology today, and you won't need to implement more costly or complex technology to execute at scale. With these mitigations in place, you'll be able to see immediate, real operational benefits without a ton of extra equipment that you have to set up. So this leads to things like faster response times by having a sensor on site that can be launched remotely, and ultimately a reduction in truck rolls out to locations. There's an added safety bonus here too, of providing your personnel in the field with situational awareness before they arrive on site. During a downed power line event, for example, knowing where those lines are and being able to see the environment ensures that personnel can arrive prepared for the emergency and remain safe while resolving that emergency. So now that we've covered the underlying tech and the strategy that we use, let's map this across to some of your use cases. So we're going to cover a few major categories of operations being undertaken today from a regulatory context. And then I'm also going to go into some of the use cases that fit within those categories to really connect the dots between the regulatory process and what you'll see operationally. So beyond visual line of sight operations with a visual observer come in two flavors with Skydio equipment. The first here is the remote pilot being out in field and functioning as that visual observer. So this requires a Part 107.31 waiver. And when thinking about the benefits of waived operations with the remote pilot in the field, what this does is really increase the range that the remote pilot can operate. This increase in range reduces the amount of time that that pilot is going to spend repositioning to complete their mission, pushing up that efficiency. Additionally, for more complex environments where there's a lot of structures that the drone is going to be moving in and out of, you don't need to continually reposition to maintain that visual line of sight as it's navigating around structures. Now, the second flavor beyond visual line of sight with a visual observer is something we refer to as remote ops without a dock. So this involves the remote pilot being off-site and having a visual observer on-site. Now, the big advantage here is that you don't need to train all your frontline staff to be remote pilots on top of their day jobs. With a handful of people that are specifically trained as pilots, you can support flight operations across the entire service area, and you don't have to ship those pilots all over the place. So this carries the same operational considerations as the remote pilot being on site, but it lets your drone program be a lot more flexible and responsive across your service area. Now, both of these can provide benefits to your program today. As you can see on the right side, these staff are able to document assets and components without needing to lift themselves to the top of that asset, which increases the safety for your personnel. And one added benefit with the X10 is that you can also collect geometric thermal imagery at the same time, providing greater insights into the health of your assets. So when we're looking at that stage 3 moving to fully remote operations, these use that ADSB and shielding combination. So the first category here involves operations over general areas that don't qualify as critical infrastructure. And this requires a Part 107.31 waiver to be obtained. So this is where remote operations really start, where that drone is gathering data with no personnel on site. The shielding volume is 50 feet around obstacles, obstructions, and man-made objects, which is the technical term for most things that stick out of the ground. The shielding volume supports many of the inspection and monitoring use cases that we see in utilities today, from looking at insulators on lines to checking gauges. These operations require the sensor to be relatively close to the asset to be able to actually get that information. So when we're thinking of the specific use cases and the advantage that you see with stage 3, the benefit is being able to get that data without needing to roll the truck and move a person to the site. So those missions can be flown manually or using pre-planned missions. So if you have a routine inspection that you need to conduct on a set schedule, you program that mission once, and the drone is going to repeat that same mission every time. Because there are no personnel on site, that remote pilot can connect to the aircraft from the office, execute the pre-programmed mission, and get that data back without ever having to roll a truck or go out into the elements. And with this workflow, you can really start developing your strategies to transition from time-based maintenance to condition-based maintenance. Ultimately, that transition involves a lot of data management, and understanding how you get that data into your systems is the first step. So with Dock and remote ops here. The next phase of shielding is operations over critical infrastructure, which requires a 107.31 waiver. Now, this permits operations up to 200 feet across the operations area and up to the height of any structure that is higher than 200 feet. So this increase in altitude supports more efficient mapping and other large area operations, as well as digital twinning efforts for larger structures. When we're looking at the use cases, there's a similar thread with non-critical infrastructure shielded operations. And again, big advantage, not rolling that truck to put personnel on site to conduct a mission. So this supports things like substation inspections, allowing you to conduct fully remote operations there, and gives you the ability to automate those inspections. So those pre-programmed missions take advantage of that Skydio onboard autonomy that we were talking about earlier to provide you with precise positioning of the drone within the substations. So this means that when you take a picture of a gauge, you can be sure that the drone and the camera are going to point in the right direction from the right position every time. The same critical infrastructure shielding applies to your power generation facilities. And again, operations at high altitudes supports more types of operations. So when considering a power generation facility, you can inspect the assets, document the construction of expansions at the site, or conduct perimeter security missions and check your fence lines. And we work with you to ensure that the waiver application is as flexible to your use cases as possible. Now, when considering inspection at a power generation facility, that workflow is going to be very similar to how you fly the rest of your inspection missions with Skydio equipment. This repeatability across use cases makes training and safe operation a lot more streamlined for your remote pilots and really helps ensure that you have reliable and repeatable data collection across your entire service area. So now that you have some context on where utility inspections are today from that regulatory perspective, we're going to go back to the central digital monitoring and look at that a little bit more. So central digital monitoring, which is sometimes referred to as one-to-many operations, takes the advantages we discussed for remote operations and increases the scale without increasing that headcount. Flying multiple aircraft at the same time inherently increases the workload of a pilot, so additional automation is necessary to ensure that the pilot can manage that workload without a loss of situational awareness or safety of flight. Without that automation, the pilot is unable to control more than a few systems at once safely, and there is a regulatory limitation that says you can only operate one drone at a time. Now, the core autonomy that we discussed earlier is a key component of enabling this step in driving efficiency and repeatability for remote inspection operations. And operations in this category involve a 107.31, which is beyond visual line of sight waiver, and 107.35, which is that one pilot to one aircraft regulation that I mentioned. Skydio has already received a waiver of 107.31 and 107.35 for internal system use, and we've demonstrated a viable regulatory pathway to enable this functionality. So when it's fully released, we have that pathway to obtain approvals for your operations. Now, there are a few key takeaways that I want to hit on again. Skydio works hand in hand with our customers to make not only the regulatory process, but setup, install, and operation as straightforward as possible. We know that aviation regulations are not your day job, and we do our best to make sure that they don't limit what you need to do to get your work done. Skydio has the regulatory expertise to maximize what you can achieve under a waiver, and we leverage that to get the most out of your approvals, while still being able to get that yes from the FAA. And finally, there are well-defined regulatory pathways to enable your missions today. As an industry, drones have come a long way in the past 10 years, and we're able to take advantage of many of the historic lessons learned to deliver that value to you without needing to reinvent the wheel and learn those lessons yourselves. So I know we covered a lot of ground here today. So I want to open it up for questions with the time that we have left. All right. So first up here, Corey Ross, are utility BVLOS COAs dependent on remaining within the bounds of their properties? If not, would that commitment make obtaining the VLOS COA easier? So as far as BVLOS waivers, um, the way that we generate those, we sit down with you ahead of time and define the operational areas. So as far as the property type itself, your property that you control access to has a lower ground risk because you know whether people are going to be there or not. And that makes the ground risk argument a little bit clearer. Now, as far as operations along your right of ways, that's not necessarily your property, but you have access to it. And so, like I was talking about with the PG&E waiver at the beginning, we were able to get the waiver for operations both within their property in the substation and along that right of way. So one thing to keep in mind there is that there's still a regulatory requirement that you don't fly over people. And being over your property and your right of way helps ensure that you're not going to be operating over people. Additionally, with the X10, we have a parachute that's going to be coming out. And that parachute coupled with the X10 is going to be able to support beyond visual line of sight waivers that will include operations over people. And so that pathway is going to be a lot more streamlined moving forward here. So next up is Daniel Saint. Do you need a radar system to clear the airspace in order to operate the UAV remotely? No, you don't need a radar system when you're operating with that combination of shielding and ADS-B. The shielding helps limit the number of aircraft that would potentially pose that collision risk just inherently. And then the ADS-B covers all cooperative aircraft in the area. So those two pieces in combination are sufficient to provide high confidence that that airspace is cleared. All right, Jeremy Storer, is the last phase of the evolution from time-based maintenance to condition-based maintenance essentially eliminating the need for human intervention on each individual flight using automation, etc.? Yes. So humans generally are bad at monitoring tasks, which involves just sitting and looking at a thing for an extended period of time and trying to identify change. Drones are really good at what we call the dull, dirty, and dangerous. And monitoring flights are usually fall into that dull category. So the advantage here is that the drone goes out, collects that information, pushes it back to you, and then from there, either you're running image processing models on top of all that data that's been collected, and then where a fault is noted or something out of the ordinary is noted, that's when it gets pushed to a human to look at it and interpret what's going on. So humans are very good at interpreting things from imagery, and drones are good at the boring part of collecting all of that imagery. So that ultimately becomes the breakdown in that end state. Curtis Day, what is the maximum distance an autonomous flight can be from a dock for a BVLOS operation? So this is a little bit of a complicated question. As far as the regulatory side, the maximum distance is however far we can make the safety case. So fundamentally, that boils back down into the equipment. So right now, the kind of rule of thumb that we're using is 2 statute miles, and that's based on command and control link, the battery life for the aircraft, etc. And so, that's more of an operational limitation than it is a regulatory one. As battery life improves, endurance improves, and command and control links improve, the regulatory part is not going to be a blocker to expanding that range. And then Jeremy Storer again, are the regulatory successes so far all within the US, any in Canada? So personally, I have worked on some SFOCs in Canada while I was at a previous job. So I have some experience there. As far as Skydio, what we talked about today was all in the US. And everything here has been kind of FAA centric. As far as Transport Canada, they have a lot of similarities between the FAA and themselves, but we're continuing to work with them. So I think that is all the questions that I'm seeing in here. So yeah, I'm gonna wrap it up. Again, thank you all for attending. My colleague Corey Hitchcock, as well as TF Butler from Dominion Energy, are going to be talking about conducting remote asset inspections from your office chair on August 7th. And that maps back to that stage 3 fully remote operations. You can find a link to register for that in the chat, and I want to thank you again for joining.